Assalamualaikum warahmatullahi wabarakatuh. Today we're going to discuss about application of differentiation related rates. Today we will discuss about introduction of definition, problem statement and solution, and application of differentiation daily life. So, what is differentiation? Differentiation can be defined as finding derivative or rates of change of a function. In contrast, to abstract the nature of theory behind it, the practical technique of differentiation can be carried out by algebra, manipulation, use of three basic derivatives, for rules operation, and also knowledge of function manipulation. Next, related rates. Related rates can be defined as involve two variables that change at the same period of time, possibly at different rates. If we know how the variables are related, it's easy to figure out how fast the other change. Usually, involve writing equation relating with the variable and taking derivative with respect to time.
Next is our problem statement. First, our first problem is a thin sheet of ice is in the form of a circle. If the ice is melting in such a way that the area of the sheet is decreasing at rate of, find the related rates of the radius decreasing when the area of the sheet is. Second problem is water is draining from the bottom of a cone-shaped funnel at the rate of the height of the funnel is 2 feet and the radius at the top of the funnel is 1 feet. Find the related rates of the height of the water in the funnel changing when the height of the water is 0.5 feet.
So, let's start with the question 1 solution. The first step in solving this problem is identify the information given in the question. From the questions, we know that dA over dt is equals to negative 0.5 and A equals to 12 meter square. And the question wants us to find the dA over dt value. Next step is we have to identify what is the formula that we want to use. In this case, we are going to use the area of sphere formula, which is A equals to 4 pi r square. Next, we have to differentiate the formula, differentiate both sides, and it's going to be dA over dt equals to 4 pi to r dr over dt. And then substitute the value of dA over dt given in the question. Negative 0.5 equals to 8 pi r dr over dt. But we don't know the value of r yet. So from the area formula, we can determine the value of r by substitute the value of area given in the formula. From the formula, A equals to 4 pi r square, substitute the value of A, 12 equals to 4 pi r square. So for r, and r is going to be square root of 3 pi. Now we can substitute the value of r in the differentiation process and solve for dr over dt. Substitute the value of r, negative 0.5 equals to 8 pi square root of 3 pi dr over dt. So for dr over dt equals to negative 0.5 over 8 pi square root of 3 pi, and the final answer for dr over dt is negative 0.0204. This means the radius is decreasing at the rate of 0.0204 meter per second. Let's continue with the question to solution. Same as the previous questions, we have to identify the information given in the question first. From the questions, we know that the value of dV over dt is equals to negative 0.03. The height of the water is 0.5 feet. The radius of the funnel is 1 feet and the height of the funnel is 2 feet. Next, we identify what is the formula that we would use. In this case, we are going to use the volume of cone formula, which is V equals to 1 over 3 pi r square h. From the formula, we need to express R in terms of H to continue with differentiation. We assume that R over H is equal to 1 over 2. So for R and R equal to H over 2. Now we can substitute the value of R in the formula and simplify. And it's going to be V equals to 1 over 12 pi H cube. Now we can continue with differentiation in the formula. It's going to be dV over dt equals to 1 over 4 pi H square dH dt. Next, we can substitute the value of dV over dt and the height of the water from the question. The question is going to be negative 0.03 equals to 1 over 4 pi 1 over 4 dH over dt. And now we can solve for dH over dt value, which equals to negative 0.03 over 1016 pi. And the final answer for dR over dt is negative 0.1528 feet per second. This means the height is decreasing at the rate of 0.1528 feet per second.
So in conclusion, differentiation is actually is a significant concept in calculus, and it has a numerous real-life application. So many fields, including physics, engineering, economy, and biology, rely on differentiation to find the range of chain of specific variables. So the concept of differentiation is vital in determining the behavior of a system and how it responds to different stimuli. In this section, actually, I will explain to you the various applications of the differentiation in life, providing their example as well. So for the first one, let's take a look in physics. So differentiation play a crucial role in physics, particularly in mechanics. In physics, differentiation is used to find the velocity and acceleration of an object. So, for example, when a car is moving, its velocity and acceleration are continuously changing. So, by calculating the rate to which these variables are changing, is essential in predicting the car behavior and how it responds to different conditions. So, for the next one is in engineering fields. So, in engineering, differentiation is used to find the rate of variables in a system. So, for instance, in electrical engineering, differentiation is used to find the rate of change of voltage and current in a circuit. Meanwhile, in mechanical engineering, differentiation is used to find the rate of change of pressure and temperature in a gas turbine. So let's move on to the next industry, which is in biology. So in biology, differentiation is used in the study of population dynamics. So for instance, when studying the growth rate of a population of bacteria, differentiation is used to calculate the rate at which population is growing. And for the last industry that use this application of differentiation is actually economics. So in economics, actually the differentiation is used to calculate the elasticity of demand, which is the rate at which quantity demanded changes concerning change in price. So the elasticity of demand helps businesses to actually determine the optimal price for their goods. So differentiation is also used. Moreover, differentiation is also used in finance to calculate the rate on investment. So actually there is a lot of application of differentiation in other industry, but I take 4 of these because I think this 4 is the main one and the most close and beneficial to all of us.